Hello, this is Dr. Zach, and it's finally time to connect the addition problems, your sequences, to finding the area under a curve. Let's get started. Hello, everyone. So, your lesson preview, you had to use 4 rectangles and no calculator to approximate the area under the curve. So, perhaps you used delta x so that all of your delta x were the same length. You were not told that you had to do this though. So if you did, you use your points 0, 0, then you had 4, 2, 8 with 2 root 2, and 12 with 2 root 3. Afterwards, you found your lower sums using the lower values for each of your points, and you also used your upper values for each of your points, and that is fine. Make certain that you do not simplify, since this is not a calculator problem, but if you did, you probably came up with the lower bound sum and your upper bound sum, and you know that your answer is somewhere in between. But recall, you were not told that delta x had to be all the same length. So maybe if you use the points 0, 0, 1, 1 for 2, 9, 3, and 16, 4, you could have gotten an answer that was a little bit easier to calculate. So make certain that you're super clever whenever approaching a problem. So in general, area is approximately equal to the sum k equals 1 to n f of ck multiplied by delta x of k, where f of ck is the height of a rectangle and delta x is the width of the rectangle. Now we're going to use the notation delta x of k because, remember, your delta x could have varying lengths. If you're told to use right-hand endpoints, your c sub k, or the x value, is going to be a plus k delta x. If you're using left endpoints, your c sub k is going to be a plus the quantity k minus 1, that shifts it 1 to the left, multiplied by your delta x. And for midpoints, you want to take the average of the right and left endpoints, and that would be a plus your 2k minus 1 over 2 multiplied by delta x. Now, unfortunately, for your upper and lower areas, you're going to have to individually assess each one of those problems or write a computer program to do it for you. For our first example, we want 10 rectangles and left endpoints to approximate the area under a curve. So given that x equals 2 and x equals 6, we're going to let a be 2 and b be 6. Your delta x, we're going to use the delta x so that they have the same length. It's going to be 6 minus 2 divided by 10, which is, of course, 2 over 5. Your c sub k, remember, was a plus k minus 1 times your delta x. Fill in the information you know. This is 2 plus k minus 1 times 2 over 5. A little bit annoying. So we're going to simplify it. And when you simplify your c sub k, you get 8 over 5 plus your 2 over 5k. All right. Now, we need to find the area. And area is approximately equal to the sum k equals 1 to n f of ck multiplied by delta x. Put all the pieces together. For our particular problem, area is approximately equal to k equals 1 to 10 f of 8 over 5 plus 2 over 5k multiplied by delta x, and delta x, remember, is 2 over 5. So this will look familiar. We're going to factor out the 2 over 5 because that's constant, and then we will do some substitution. Now you have to decide, is it worth just substituting in 10 times, or do you want to use your algebra to simplify? I'm going to use algebra. So I have 0.25 times my 8 over 5 plus 2/5 k, and that will be squared. Multiplying this expression out, I never said this was lovely. We're going to have 2/5. Now, the 0.25 is actually, I forgot my plus 1. Let's put that plus 1 in here. Don't forget that. It came from right there. All right, so I can't factor out that 1/4 like I was hoping to. Instead, I have to multiply everything out. K equals 1 to 10. Let's use the fraction 1/4, make life easier for ourselves. We will have 64 over 25 plus 2 times 8 over 5 times 2 over 5 k, and plus 4 over 25 k squared plus 1. And notice all of that needs to be multiplied by 1/4. Keep your brackets and your parentheses straight. You don't want to have any mistakes because of that. All right, continue working. This is now equal to your 2/5. Sum k equals 1 to 10. Let's clean this up a little bit and multiply through as well as simplify. So this would be 1/4 times 64 over 25 plus the sum k equals 1 to 10, 1/4 times 2 times 8 times 2 over 25k, we're getting there, plus 1, the sum again, k equals 1 to 10, 1/4 times 4 over 25 k squared, and of course that extra 1 is just plus the sum k equals 1 to 10 of 1. All right, now you know what happens next. We need to rewrite this problem so that it only has numbers. We're going to have 2/5 times, now remember, 1 over 4 times 64 over 25. That's just a constant, so we're going to multiply it by 10. Plus, now the next one has all these constants. Let's write 8 over 25. K is sitting there, so when we evaluate, it's 10 times 11 divided by 2. Look at that. That was very useful. Then we will have plus, the next term is going to be a nice 1 over 25. Then for k squared, we have 10 times 11 times 21 all over 6, and our last expression is plus 10. When you simplify all of that, what you know is that your area under the curve is approximately 19.76, and you need to fill that part in, units squared. So 3 decimal places. See if you can figure out that last one. I think it came out to be 494 over 25. Maybe there is no other decimal. All right, a lot of work. Don't worry. Once we practice a few of these, you know there has to be a shortcut. Let's look at example 2. All right, now we're going to find the area under a cubic from x equals -2 to 4 with 100 rectangles. Insane, I know. We're starting at -2, we're ending at 4. There will be different areas, of course, depending on where you start. To find your delta x, I'm going to once again use the same size delta x unless you really want to add up 100 rectangle areas, and you go right ahead. That does not sound like fun to me. So there we are. In this problem, you're supposed to use right-hand endpoints. So c sub k is -2 plus k times 3 over 50, because remember it was a plus k times delta x for your c sub k. All right, now it's time to substitute. We know that area is approximately equal to the sum k equals 1 to n, and then we'll have f of ck multiplied by your delta x. So in our particular problem, the area is approximately equal to k equals 1 to 100. F this time was x to the third, so we're going to first write f of -2 plus k times 3 over 50, and that is multiplied by 3 over 50. Do some algebra. This is the sum. Your k equals 1 to infinity to 100. Do not skip that step. When we multiply this out, we can factor out our 3 over 50. We're left with the sum of the quantity, -2, plus 3k over 50 to the third power, and then we're going to subtract 1. Make certain you have your brackets in the right place. Yes, we are going to multiply out that cubic, but you remember Pythagorean's triangle, and that's going to make this a whole lot easier. You've also been doing your practice. K equals 1 to 100. When we multiply this out, we get -2 to the third power plus 3 times -2 squared times your 3k over 50. Then we will have the next term, which will be plus 3 times 3k over 50 squared times -2. And then we will have, of course, don't forget your plus 3 to the third, k to the third over 50 to the third, minus 1. Yes, minus 1. Don't forget that minus 1. All right, double check that everything looks good. And then we're ready to multiply things out. Let's do this. So this is now the 3 over 5 sum. K equals 1 to 100. Let's call that -9. Put those together. Plus, then we will have our 3 times 4 times 3 over 50, the sum of k. Notice once again that I am rewriting the problem so that the summation notation is one of our 4 known pieces. Next part, we have 27 over 50 squared times -2k, sum, k equals 1 to 100, k squared. Third part, right here, we will have a plus 27 over 50 to the third, sum, k cubed for k equals 1 to 100. All right, no worries, we're doing great. Next, we take that 3 over 50. Somehow I lost the 50. So we have 3 over 50 times, put it all together, -9 times 100. So that piece is negative. So some of it was actually underneath the axis when you were finding your area. And then we have plus 3 times 4 times 3 over 50 times 100 times 101 over 2 plus -54 over 50 squared. Now what about k squared? That term, as you'll recall, would give you your 100 times 101 times 201 divided by 6. And now the next piece, plus your 27 over 50 cubed. Yes, that looks like a big number. K to the third is 100 squared times 101 squared divided by 4. Now, if you take the time to simplify this, you should come up with it equals 56.171 units squared. All right, so that was a lot of work, but you are definitely going to have a shortcut very soon. For number 3, you're told to estimate the area under the curve given g of x from x equals 0 to 1. Using midpoints, make 3 rectangles. Okay, so for this one, I do not suggest that you use a formula with summation notation. Just do the work. Your delta x is 1 minus 0 over 3, or 1/3. So what do we know? The area is approximately equal to your 1/3 times g at 1 over 6. Remember, we're using midpoints. Plus g at 1/2 plus g at 5 over 6. So these midpoints, where do they come from? I suggest you make a number line. On that number line, you're going from 0 to 1. Cut it into thirds, and then you will be easily able to find those midpoints. Now substitute. Your area is going to be 1/3 of 1/2 plus 1 plus 1/2, which will be 2/3 units squared. Now, when we're looking at example 4, approximate the area under the curve, 3x plus 1, using n rectangles. Dun, dun, dun. So now you're getting into formulas. Love a good formula, because formulas lead you to shortcuts. So delta x is going to be 7 minus 3 over n, which is 4 over n. That's good. Your c sub k. Now, using the left endpoints, that's going to be 3 plus the quantity k minus 1 times your delta x, which is 4 over n. Simplify, and we get 3 plus k over n minus 4 over n. So we're told to use n rectangles. That means we have to use summation notation. We'll go from k equals 1 to n. And then we will look for function f at 3 plus k over n minus 4 over n. Now, do not worry. This is multiplied by your delta x. The reason this isn't going to be so hard is because the function that we're working with is linear. So when we substitute, we're going to get the sum, k equals 1 to n, substitute into 3 times 3 plus k over n minus 4 over n. There's that piece. I probably shouldn't put that n 4 over, yeah, it's fine out there. Let's do that. There we go. 4 over n is still out there. But do not forget your plus 1. I'm terrible at that plus 1. All right, it is back. So what do we do now? You will simplify it. You've got to work it out to find that exact area. And what you're going to get once you multiply and simplify is 46 minus 42 over n. Now, I want you to think for a minute. What would happen if n went to positive infinity? You would get the answer is 46. And what do you think 46 represents when approximating the area under a curve? You were right. When you are looking for the exact area, you take the limit as n goes to infinity. So this answer became the limit as n goes to infinity for the function we were playing with, 46 minus 42 over n. Your n went to 0. I'm sorry, your 42 over n went to 0, and the answer was 46. That is the exact area under the curve. So there, we have gotten to a point where we now have some new notation. And that notation is basically the sigma notation with the limit and the delta x. Notice your delta x is now written as a dx. You have a differential, and you have just stepped into an antiderivative. So to determine the exact area under the curve, you will use an infinite number of rectangles. Your f of x is perpendicular to the x-axis. We know that because dx and delta x are cutting the x-axis, which should lead you to question, what would dy and delta y represent? Yes, cutting the y-axis. All right, you have 5 questions that I want you to practice. So give these a try. Only work for 30 minutes. Don't work for longer than that. All right, so I want you to complete this Unit 7, Day 3, exact area under the curve worksheet. Then you're going to have a small assessment. So get some practice and then take that assessment. You have a fabulous day.